Question 13 is just a perpendicular bisector. Asks me to construct a line 7 centimeters long, which I'm going to do here, and to construct the perpendicular bisector to that line. This one I don't need to measure anything apart from my original line. As long as I'm keeping my compass point and the pen point at a distance, it's got to be more than halfway, but not too much more than halfway. And I've got to keep the distance set at the same distance all the way through this. So as I lift up now, I don't move the distance between those two. Move the point to the other end, go there, and then connect those 2 points there. Question 14, a little bit more difficult. It asks us to draw a line ST and a perpendicular going through the point M, which is above the line. I'm just going to draw that there, above the line. And this one, what we effectively want to do is create a shorter line that we can then do a perpendicular bisector of. So I'm going to find points from M that go through this line on an arc. I've got a point there, and a point there, and then without moving those distances at all, I'm going to create the perpendicular bisector through that. Obviously I've got M already, but I need an arc on the other side. And here again, where the arc crosses exactly, and check that it goes through M, and then draw the other side there. I'm now going to connect M and this new point created by the arcs, and that is a perpendicular bisector at M. I keep on saying bisector, I mean perpendicular at M. Perpendicular. I can check that it is perpendicular, and it is exactly as it should be. Question 15. We've got a bicycle moving along a flat road. Quick sketch of the bicycle in 2 different positions. First of all, we're looking at a point there, and as the bicycle travels down the road this way, we can see that that point on the wheel is just going to be going in the same point, same place, if the road's level. So for part A, we have a picture of the road, and the picture of the point in the centre of the wheel, which is just travelling along equal distance from the road for its whole length. For part B, a bit more difficult, we've got a point that's on the wheel. Now as that moves forward, it's going to be moving down like this, because the bicycle's moving forward, until that bit of the wheel has come down to there, which will happen after a half turn. Then if we think about what happens after that on this wheel, the bicycle's still moving forward, so the next section will be up a bit, but by there the wheel will be over here, and then it will keep on going up, but the wheel keeps moving forward, so this happens until it reaches here at the top of its arc, and then it's going to go down again like it did there. So the effect this has on the locus is that it will be going constantly up and down, but at the top of the arc it's going over, whereas at the bottom the bottom of the wheel hits for only a small part of the journey. So it hits very briefly and then rises again to the height of the wheel, and we'll keep on doing that repeatedly.